Welcome to the fourth video of this series. Today we will see a very interesting and very hard problem, which is like finding the median of two sorted arrays. So here we will be given two sorted arrays of integer, and we need to find the median. But we need to find the median in log of m plus n time, where m and n are the length of the two arrays, uh, and uh, and it becomes hard because of this constraint. We'll see the brute force solution that will be very easy to implement. But let's first understand what the median is. So basically, median is the middle element of the sorted array. So when we combine both the arrays and sort it, the middle element is our median. So in if the number of elements is odd, then the middle element will be our answer. If it is even, then we need to add both the elements, both the middle elements, and divide it by 2 and return the answer. So we can see here the number of element is 3, so median element becomes 2. Here we have even number, so we will take the two middlemost element like 2 and 3, divided by 2 and return the answer. So let's see how we can implement the brute force solution. So basically, if we have to return this answer in log of of n plus n time, like that is a linear time complexity. What we can do is we can combine both the arrays and then simply find the middle element, like that is by using formula m plus n divided by 2, and if it is odd, then return the middlemost element. If it is even, then use both the middle elements and return the answer, right? So how we can combine both the arrays? Both the arrays can be combined in linear time, because if we combine both randomly both the arrays into single array and then try to sort it, then that will become uh, n log n time of complexity, right? Where n will be, basically when I say n, it's like m plus n log m plus n, because that's the time complexity of sorting algorithm. But since the arrays, both the arrays are already sorted, we can combine that in of n plus n time. How we can do that is like we can keep two pointers on the start of each array, and wherever the pointer is pointing, compare both the elements, and if the element is lesser than that, add it to the merged array and move the pointer from that array. So here we will compare 1 with 2, 1 is smaller, add 1, move the pointer to 3, then compare 3 with 2, 2 is smaller, uh, add 2 to the merged array, and basically here all the elements are exhausted. Then we will keep iterating on the remaining elements of the first array, and then we will add all the elements. So this will give us the sorted array in of linear time, that is of n plus m time complexity, and then when we can easily find the median. But here the challenge is that we need to find in the log n time, right? So whenever we hear log n time complexity, we should always try to think in the binary search direction. So basically, we need to come up with the approach where we can apply a binary search directly on this two sorted arrays. Okay, so let's do some observations here. Okay, so basically, if we try to come up with a partition uh, in the two arrays, okay, L- let's imagine like we are somehow able to divide both the array A and array B into two parts, okay. Then all the elements on the left part will be lesser than all the elements on the right part. So uh, so how it works, like so imagine, let's say you have to merge both the arrays. Okay, we have to create the combined array from both the arrays. Then it will be like 1 2 3 4 5 6 7 8, right? That will be the order of elements. Basically, all the elements on the left side of the median will be smaller, and all the elements on the right side of the median will be greater. That is basically the definition of median, right? So we have to come up with the partition such that here all the elements should be lesser than the right side of all the elements, right? So basically, if we are dividing it into two parts, so 3 should be lesser than 6. Why we are not comparing with this? Because it's a sorted array, right? So any element on the left side of this will be smaller than any element of the right side of this. What we need to compare is 3 lesser than the right of the second array, correct? And next condition should be 4 should be lesser than right side, like uh, this element should be greater than, sorry, should be lesser than the right of this element, right? If these two condition meets, then only we can see all the elements on the left of the partition are smaller than all the elements of the right of the partition. So let's say somehow we are able to come up with this partition. So that partition should satisfy at least one condition. The max of the max of left side of array 1 should be lesser than the minimum of all the elements in the right side of array 2. And similarly, the max of all the elements in the array 2 should be less than the minimum of all the elements on the right side of array 1, right? So this is what we are doing. Max left of array A should be smaller than min of array 2, right side of array 2, right? Then max of left array B should be lesser than min of right array A, which is 5. If these two conditions satisfy, we can easily say that all the elements in the left of partition combined, like both the arrays combined, is lesser than all the elements on the right side of the combined array. Okay. Now, one more condition needs to be satisfied for finding the median. So, if we see that median is the middlemost element, right? So, number of all the elements on the left should be equal to number of all the elements on the right, correct? This there will be one exception case when the total number of element is odd. In that case, we will put one extra element on the left. So at least this condition should be satisfied, that all the number of elements on the left of partition should be equal to number of all the elements on the right of partition, and it can be one greater than the number of elements on the right. So if both these conditions are satisfied, right, then we can easily find the median. How we can find the median is, let's say let's say if total number of element is odd, okay, then we can return just simply the uh, max of all the elements on the left, correct? So elements on the left is like 3 and 4. We need to combine just between these two, and we need to return the max, because left will always have one more element than the right, the way we will do the partitioning, right? So that will be our middle element, correct? So whatever is the max on the left, that will become the middle element. In case if the number of elements are even, then we have to find max on the left, minimum on the right, and add it and divide by 2 and return. Right? So hope this is clear. So here if we see example, the number of elements are even, then we need to find max on left, which is 4, minimum on right, which is 5, add and return the half of the right. So hope this logic is clear, but we will do some dry runs, and we'll see how we can write the code of this, and it will be more clear then. So so now how do we find that partition? Okay, so let's try to see like how we can cut this array. So imagine array A is our smaller array, array B is our bigger array, larger array. Okay, so either both can be equal or one will be smaller and other will be bigger array, right? So we will always try to do a binary search on the smaller array and try to create a partition P1 here, and then we will automatically have a partition P2 on the second array. See, we need to understand that these two partitions on the array are not independent of each other. Why I am saying that? Because let's say the way we are creating partition, we need to satisfy this condition. The number of elements on the left should be equal or just one more than the number of elements on the right. Okay. So if I say I want to create partition here, that is on the middle side. So let's say I am creating partition on the index one. Okay, index one. Uh, by index one I mean like two. So basically, if I choose the partition two here, like P1 as a two, P1 is the partition on array A, and P2 is the partition on array B. Okay. So let's say if I choose P1 as 2, that means two elements on the left, then P2 is automatically fixed. How it will be fixed? Because we can find P2 by this formula. So number of elements, total number of elements will be m plus n. Okay, and if we divide by 2, that will be the total number of elements which can be on left, right? So if I ask you like what will be the total number of elements which can be on left, okay, on the left side, so that will be the number of elements uh, behind P1 partition plus number of elements behind P2 partition. Okay, and that number will be m plus n plus 1 divided by 2. So if I have to find total of all the elements on the left of partition, what will be that number? That number will be m plus n plus 1 divided by 2. Why I am saying? Because if it is a odd number, right? If it is a odd number, then we have to add one, and it will give the correct answer. Like this will be, let's say there was one more element, a 9 here. Okay, then it will automatically give 5 value here. So 5 plus 4 will be 9 plus 1, 10 divided by 2, 5. So it will give automatically give 5 elements on the left. So here it's fixed, like how we can calculate the number of elements on the left side. That will be always m plus n plus 1 divided by 2. This is very important. If you understand this, I think it will be very easy to understand the entire solution. So I will reiterate that how we can find the total number of elements on the left of the partition. The total number of elements will be always m plus n plus 1 divided by 2. Why we are adding 1 here? It will take care of putting one extra element on the left, because let's say if it is a even, then it's not a problem. 8 plus 1 9 divided by 2, it will be 4.5, but rounding of to nearest integer will make it 4. So this element is coming perfectly fine. But if it is a odd, 4 plus 5 9 plus 1 10 divided by 2 5. So this will give like 5 elements on the left side. So this is crystal clear now that this is the formula to find the number of elements on left of partition. Then let's say if I'm choosing P here, P as 2, then automatically P2 is fixed. P2 will be always this minus P1, the number of elements on the left on left of the array 1, that is array A, correct? So P2 will be always fixed. And this is very important. Like these two partitions are not independent. If we move this partition to here, then this will automatically move here. Let's say if I am saying that first partition is P1 is after 5, that is 3 elements are on the left. So P1 value is 3, then automatically P2 value will be 1 here. This will move here. So both are not independent of each other. Once we fix one partition, next will be calculated by this formula. That's why we only need to care about doing a binary search on only one array, because if you do binary search on one array, we can easily find the partition on the second array, and this makes it very interesting now. Like this was the most difficult part to understand, that if we do binary search on one array, we will automatically partition the second array. Automatically it will be done. Cool. Now which array to perform binary search? Okay, so we will always perform binary search on the smaller array, just to make P2 as non-negative. So if P1 is if m be the length of first array and n be the length of the second array, like the larger array. So m will be smaller, n will be larger. So in that case, range of P1 will be 0 to m. Okay, range of P1 will be 0 to m. So here what P2 can do, P2 will be always will be something like this. If you try to put both the ranges here, okay, if you try to replace P1 by 0 and P1 by m, then here the answer will be like, if you try to replace P1 by m, then it will be n minus m plus 1. Okay, so n minus m will be the value of P2. If n is not the larger size, then P2 can become negative. That's why we are performing binary search on the smaller element, so that P2 never becomes negative. So this is the condition we will be following. You understood, right? Like if you replace P1 by m, then this will become n minus m plus 1 by 2. So if n is smaller, then this can become negative. So that's the reason we want to perform binary search on the shorter array. Now let's try to do dry run here. How we can see this effect coming. Uh, so let's say we are doing binary search on smaller array A. So first partition will be 1, because low will be 0 and high will be the length of the array. So in this case, array length of array 1 is 2. So our first partition will be 1. Okay. So first partition in 1, then automatically P2 will become 3. We can calculate using this formula, right? M plus n. So m plus n will be 5 plus 2 7 plus 1 8. 8 divided by 2, I guess. 2, yes. So that will be 4. So total elements on left side should be 4. 1 we have already chosen, like P1. Then here it will be 3. So P2 is 3. So we will check the condition of binary search now. So what was the condition here? The left of 100, max of A1 should be lesser than the minimum of second array. So here we check, like max of left is equal to 100, mean of right of B is equal to 4. Okay, so this condition fails, but one condition is satisfied, where max of B, which is 3, is lesser than min of A, which is 200. So this is satisfied, but first condition fails. Okay, that means our max of A is much greater than the min of B area, right? So this is much greater than this. So that means we need to move our partition to the left, because we want to uh, reduce like the size, like we want to go left because here the number of elements will reduce on the left side. So now our new high will become p1 minus 1, that is 0. So this will take care of shifting all the elements of a to the right of the partition, because just now we saw like this element is much greater than the right of minimum of element on the right side of array B. So that's why we need to shift this to the left. Okay, so our new partition will become 0 elements from A and 4 elements from the B, right? So now our next binary search will end here, because now our left array will have 4 elements and right partition will have 3 elements, 100, 200 and 5. And and in the next step we can see our answer will come to as 4. So we can see uh, now what happens. Last element of A side is left empty, use infinity. Okay, and min of uh, right of a first element of A's right side. If A's right is empty, use infinity plus infinity. Basically, it's saying that if this partition has reached here, then use minus infinity for comparison, and if it has reached on the right side, use plus infinity for comparison, right? Now we see like what will be the condition to shift the pointer. So if max left A is larger than the mean right B, A is giving two large numbers on the left half. Move P1 to the left. So we'll move P1 to the left. And similarly, if max B is larger than the mean right A, B is giving two large number to the left half, move P1 to the right. Low will become P1 plus 1. So basically it is saying that if let's suppose this was uh, lower than this, that means all the elements of this should come to the left partition. So imagine let's say there was -1 and -2 here, then this condition will be not satisfied. 3 should be lesser than uh, the right of array, right? So that means -1 and -2, all the elements should become the part of left partition. So here we will be shifting. Basically, low will be p1 plus 1 here, right? If both the condition pass, means perfect partition found. Compute the median from the four boundary values. If if all the conditions are satisfied, that means we have found the median. Hmm. As we discussed, we will calculate the final median in this format. Now let's see the solution here, like how we can see. So basically we are given two arrays, num1, num2. We need to find the median of that. We'll compare if num1's length is greater than num2, then we will just switch the array. Basically we are trying to make num1 as always smaller array. Now since this will be switched, now we can ensure that num1 is always the smaller array. So m is always less than n, and left half size is this. Okay. Now let's try to perform binary search on the smaller array, that is m. So while low is less than high, we will keep looping through it. So our first partition will be low plus high divided by 2, and P2 will be calculated by that formula what we discussed earlier, left half size minus P1. Okay, now these will be the four boundary conditions, right? So here it is just checking like if there is zero elements on the left half, then use minimum value or use this value. Okay, the similarly this like use for minimum use integer dot min, for maximum use integer dot max value, or if it is present, if it's not on the boundary, then we need to use their element value. So this will give four elements in the partition, right? Now we can easily compare that these two conditions are meeting. Max left one should be greater than mean right 2, max left 2 should be lesser than, sorry, here also lesser than equal to mean right 2, max left 2 should be lesser than equal to mean right 1. If this is there, then it's a perfect match. Then we just calculate. If it's odd, then return this value, and if it is even, then try to do this like find the max of left and min of right divided by 2. Else, if uh, max is greater than min, then we should if left max left one is greater than min right 2, then as left side is too large, take fewer elements from A. That means we have to uh, reduce like our high from P1 to P minus 1. Basically, we are shrinking the array A. Like we need to take fewer elements from the left of array. Else, B's left is set is too large. Take more elements from A. Right. In any conditions, we will be just playing with the smaller array because we are doing part uh, like binary search on the smaller array, and this will return our answer. And similarly, this is implementation in Go. You can pause and check like how you can implement the same things in Go. So here the main point is this how to calculate left half size, which is by this formula. Okay. Third, like if we have reached the boundary, then use minus infinity, that is integer min or integer max, to do the calculation or do the binary search comparison. And and when we have to do the like binary search, if array 1 is greater, size of array 1 is greater than array 2, switch uh, switch what we have done here, and then perform the same operations. So basically, if we see from the example here, what we are trying to do is, let's say if more elements are in the array B and all are shorter, that means somehow median is going to come from the array B. By this algorithm, it will be automatically adjusted that all the elements, larger elements, will become the part of right partition. So basically, if we have, let's say, 1 2 3 4 5 100 and 200, then we obviously know that median will be coming from the array B. So in that case, if we do have to do the partition, all the elements here uh, of array A, that is 100 and 200, should fall become the part of right partition. That means this partition will be here like 0. So this partition P1 will be 0, and four elements from the uh, like four elements from the second array will become part of left partition. So basically, when we are decreasing this P1, P2 will be automatically increased. and then answer will come from here. Answer will definitely come from here. And similarly, it will be the case vice versa. When all the elements here are smaller, let's say instead of 100 it was 0 minus 1, minus 1 0, then all the elements of left should become part of array 1 should become part of left partition. So in that case, minus 1 and 0 uh, will be coming on the left partition. So our P1 will be 2. Accordingly, P2 will be shifted to 2 here, 2 or 1 here. So in that case, we can find the median of the sorted array. And here, since we are doing the binary search on the combined length, it will be log of m plus n. That will be our time complexity. Hope you have understood the solution. If you have any doubt or any questions, please do comment. Thank you.